All right, it's 10:01 a.m. We're going to get started. Welcome to Advanced Kentucky's Week 4 of AP Statistics Content Review Sessions. My name is Aaron Timmons. I'm the Mathematics Content Director. I'm joined by Dr. Sherry McGuffin, our STEM coordinator, and our presenter today, Mr. Adam Shrager, who is back with us for a second week. Super excited to have him here. He's got lots of good stuff to share with us. We're going to jump right in here. I'm going to go over a few introductory slides. If you see that link on the screen, please make sure you have pulled up today's handouts from that bit.ly link. Adam's going to be going back and forth between the PDF and the PowerPoint, but if you have the PDF file in front of you, that'll be a really good reference for you to use during the entire time. This review session is intended for Kentucky audiences, but I know we've got tons of educators and students from across the country here. Welcome. We'll do everything we can to make this an equitable opportunity for you to learn. During this session, we do encourage participation, but please know any participant causing a disruption will be removed. All of our contact information can be found here on this screen. Twitter, Facebook, email. Please feel free to reach out to us if you have any questions afterwards. Your microphones will be muted the entire meeting. We ask that you leave your videos off for the entire time. If not, we'll remove you. Please use the chat feature in the bottom right-hand corner of your screen. You can chat directly with Adam, Sherry, or myself, or you can pose questions to the entire group. Sherry and I will be monitoring that chat and letting Adam know of any questions that arise. kyap2020.com is the site to go to for all of these recordings. All prior recordings will be posted here, as well as any other resources that will benefit you headed into AP exams. So please check out that website. This recording will be posted by the end of the day. So before we begin, I'm going to pause the recording for about 2 minutes here, let you open up another browser. Please sign in at this link. It will take you all of maybe 2 minutes. It's 4 short Google form questions. Make sure you have the handouts pulled up in front of you, and then we will get started. So take a few minutes here, introduce yourself in the chat, and make sure your audio is working, and we will get started here right away. All right, so I'm going to turn things over right now to Adam. He can introduce himself, give you all a little background on his AP Stats knowledge, and then he can start sharing his screen. So Adam, take it away.
Thank you, Aaron, and thank you, Dr. McGuffin. My name is Adam Shrager, and I teach AP Statistics at Hopewell Valley Central High School in Pennington, New Jersey, which is adjacent to Princeton, actually be near the ETS campus, although I don't actually get to see the exams early. So, but there's a picture of our school. We've been locked down and home since March the 12th, so we're all feeling this. I've been an AP reader and table leader. This would have been year 13. We'll see what that looks like. This year we'll be reading from home. But a lot of the strategies to maximize your performance on this exam are really going to be no different. So we want to talk today about how a student can demonstrate their knowledge and make sure that they're gaining full points when they're answering the 2 questions that you're going to be asked this year. So what we're going to do is and let me just say that it's such a pleasure to speak to. I know we have a lot of students on this call, so hi everybody. We have a lot of teachers on this call. Some of the teachers are very experienced, and some of the teachers, you know, you're new to this. So we're going to do a little walk through the course, and we're going to look at 4 AP problems. So it would be helpful if you have those 4 problems in front of you that were at the link that Aaron Timmons shared. If you're joining late and you don't have those 4 problems, perhaps we can put that link up in the chat. So today we're going to talk about strategies for free response questions. And of course, this year's exam is all free response. What we know is there's going to be 2 free response questions, a 25-minute question and a 15-minute question worth roughly 55 and 45% of the points available. So the conjecture among many teachers is that this implies that you'll have a 5-part question and a 4-part question. So this first question is going to be a little longer than typical AP problems, and will almost certainly draw on different elements of the course. Let me also emphasize as I speak that please throw questions up in the chat, and Mr. Timmons and Dr. McGuffin are going to be watching that chat very carefully and they will be interrupting me periodically. It's tricky for me to present and watch the chat at the same time. You will not need your graphing calculator this year. You will need some sort of a calculator, but a 4-function calculator will be enough. And according to Mr. Packer, Trevor Packer at the College Board, according to their survey, most students will take the exam on their Chromebooks using Google Docs. That's a direct quote. So what does that mean to us in statistics? It means you're going to be very limited in terms of the notation that you're going to have to write, because we know that ETS, we know that the AP has to keep this exam equitable for everybody. So we're projecting that you're going to show very little calculation this year. We know that we're going to have 2 questions. We know those questions are going to cover multiple units. So the units you see here on this slide are from the course and exam description. This is how teachers refer to the units. This almost certainly doesn't sync up with your textbook chapters, but we are going to look today at a question about descriptive statistics. We're going to have strategies to maximize your score. We're going to look at questions about experimental design and sampling from a population. We're going to look at a probability and what probability might look like this year, since we don't think you're going to have to show calculation, and you aren't going to need a graphing calculator. And then finally, of course, the big dog is inference. Now, in a traditional year, inference is 40% of the exam. We don't know quite what percent it's going to be, but we do know that of the inference units, the last 2 are not going to be tested. So as an AP reader, we are looking in statistics, we are looking for communication. We are looking for, yes.
Sorry, we had a question here. I know you're talking about exam format.
That's good.
This question's coming up a lot. Would you recommend doing work for the exam typed out or handwritten?
Oh, I think that's entirely to the student's comfort level. If you prefer to handwrite the exam, handwrite the exam. This is my guess, and this is the guess of many teachers. We haven't seen this new weird exam. We believe it's going to be written in such a way that the whole thing can be typed. If you prefer to sit there with a piece of loose leaf and then take a picture of it and upload that picture, that might mean emailing that picture to your laptop and then uploading that file. That's what that 5-minute time is for. I really think you're going to do whatever is most comfortable. What we learned last night, and we'll talk a little bit about the information that came out last night, is in about a week, there's going to be a testing site, and all students and teachers for that matter, you're going to get a chance to go online and essentially practice uploading a file and seeing exactly what the interface is going to be like. And I think at that time, you're going to have a really good sense of what I put on paper, or would I rather do it in Google Docs or Microsoft Word or whatever. So that's my answer. I think if this were the calculus discussion, I would be all about pencil and paper, but we know it isn't. So let's think about what are AP readers looking for. We are looking for communication. We're looking for consistent statistical communication. And what the readers have to do is we need to grade student responses consistently and according to a fixed rubric. Even if Mr. Shrager doesn't agree with every word in that rubric, it is vital that every reader is grading identically. That means that there are decisions that are going to be made about what we're looking for in a student's answer and what we're not looking for. But every exam has to be graded similarly, and we tend to be very, very strict with communication. It's all about communication. It's much less about calculation. As a matter of fact, if the student makes a calculation error and I can decipher that error, it's virtually never penalized. And I always tell my students the first day of class, statistics is not a math class. And it takes until about March until they believe me that it's really not about math. It's a whole different discipline, even though it's part of the math department. Okay. What we do know is that you're going to need the formula packet of formulas and tables. You won't need it for the next hour, but you will need it on the AP. And we're going to assume that you have that accessible. If you don't have that link, ask your teacher. Maybe Mr. Timmons, you can throw it back up in the chat like we did last week. But okay, great. It's on the College Board site. but we're going to make sure really every student should have that printed out and in front of them, because it's one of the few directions that we have gotten that students will need besides a 4-function calculator. Okay. Last night, so I updated this slide at 10 o'clock last night, because at 8:30 it was confirmed that, so this is brand new information, you will not be required to draw any graphs or any images. So what does that mean? That means from the most simple question to the most complicated question. Let's say something like a 2-sample t-test, where virtually every student is sketching 2 parallel box and whisker plots to make sure that they don't have skew. This year, you are not drawing any graphs or any images. We all guessed this. We thought this was the direction that the AP was going to go on. But last night, Trevor Packard confirmed absolutely no drawing. So that will help guide us in terms of what we should be preparing while we are at home and have very limited time with our teachers. I'm, only seeing my students 2 weeks. I see someone writing, "Oh, you're supposed to have it printed out." That's what's been recommended, that the formula packet is printed out, but if not, at least have it open in a tab. This is a question that just came up in the chat. The formula packet and the tables, what we call the Z table, the standard normal table, and the T table should be accessible to every student while they take the exam. That is some of the direction we've been given, that and a 4-function calculator. Okay, so let's talk about how to approach. We're going to go through the 4 units, and let's talk about how to approach a free response question from the descriptive statistics unit, and then we will look at a question together. Okay, so we're going to look at 1 variable data and 2 variable data, which is to say regression. When we need to communicate with 1 variable data, what do we talk about? This is, week 1 of the class. We talk about shape, center, spread, and unusual features. Some teachers teach SOCs, shape, outliers, center, and spread. So if you're asked to discuss the distribution of some data, you want to make sure that your answer touches those 4 things. The reader is going to sit there and essentially make little check marks to make sure the student has touched shape, center, and spread. Okay, what you want to be very, very careful about is if you get a box and whisker plot, and here I've had one right here. If you have a box and whisker plot over on the right of my screen, that plot is not normal. It lacks skew. But I can tell you that when you put this box and whisker plot in front of students in May, they all want to say, "Oh, it's normal," with a median of about 78, and then you might say something about the range or the IQR. That is not a normal box and whisker plot. It might be normal. What we do know is that it lacks skewness. This is important because when we read tests later on, what do? We often draw box and whiskers not to show normality, to show that it doesn't violate normality, which is to say extreme skew. So be careful, because this is a very easy way for a very, very smart student to take a score, an E, a perfect score, and have it ding down 1 level by calling a box and whisker plot that is symmetrical by saying, "Yup, it's normal," because it isn't. Okay, it's an important point in chapter 1. And similarly, it's an important point in inference problems. Okay, when we look at 2 variable data, which is to say regression, we think about strength, type, and direction. Some teachers teach it as form, which is to say linear or nonlinear. I've always discussed it as type. That's just how I learned it. And make absolutely sure that it's in context. You also want to mention outliers and influential points. So as I like to say, if you are asked about a relationship, what do you need to think about with that relationship? STDs, strength, type, and direction. Okay, it's a nice little acronym. Hopefully you're chuckling right now. But when we think, if you're asked to describe a relationship, make sure you talk about strength, type, and direction. I've read beautiful 3-paragraph answers where the kid tells me everything about the scatter plot and leaves out linear or nonlinear. And then I've read answers that are 6 or 7 words, and the kid simply writes strong, nonlinear, positive, relationship between, A and B. That's it. Strength, type, direction, and context, and that's all you need. Okay. When we're looking at relationships, we want to make sure that we can describe slope and intercept in context, R&R squared, and extrapolation. Okay. The advice would be to memorize that R squared sentence, be on the lookout for influential points, and drawing conclusions from points outside the range of data. That's extrapolation. That's all fair game for this year. I don't think we're going to have one of two questions that's devoted to regression, but most readers, most experienced teachers believe that, regression may show up in some way. So let's jump now and take a look at the first question from the question packet. And the very first question, as you can see, is a regression question. Let me tell you what I've done here. I've picked 4 questions that, for reasons that will become clear to you, I think might reflect the types of questions we see in 2020. I'll tell you why a little bit later. I also intentionally picked older questions because I'm sort of hoping you might be a little less familiar with these. So let's take a look. Lydia and Bob were searching the internet to find information on air travel in the United States. They found data on the number of commercial aircraft flying in the US during the years 1990 to 1998. The dates were recorded as years since 1990. Thus, the year 1990 was recorded as year 0. They fit a least squares regression line to the data, and then they've given you a graph of residuals. So we have the residual for the number of commercial aircraft flying and how many years have passed since 1990. We then have some computer output, and then there were 5 very short questions. Let me make a point that even though you don't need a graphing calculator on this year's exam, what we do know is that technology acquisition is still part of the test. And one of the easiest ways for the AP to assess technology acquisition is to give regression output. Okay, so the first question, let's take a look here at what little information we have. We have an intercept, we have a slope, and we have a residual plot. And the question is a line an appropriate model to use for this data? What information tells you this? Okay, I'm going to hope that you have this open in front of you so I can go back. And Mr. Timmons, if we could please throw up our very first Zoom poll. We're going to have a little fun today. The questions get more fun as we go along, but let's ask this question. Is a line an appropriate model to use for this data? Yes or no? So I believe we should get, there it is. So please only answer A or B. You can move this poll over to the right if it's blocking. Okay, we have people answering the question. Is a line an appropriate model to use for this data?
And your responses are anonymous, so feel free to put out your best guess.
Yep. No one can see your answers and who you are. Please don't pick C, D, and E for this one. The other questions have 4 answers, and they're a little more fun. This was our practice with Zoom polling. We had never really tried this. I've never tried this before. But okay, we have 20 answers. Okay, so let's end that polling, Mr. Timmons. And the correct answer is in fact A. So let me close that here. And let me close that here. And sure enough, yes. And why? Because there's no obvious pattern in the residuals. So we are looking for some kind of pattern in the residuals, which might lead us to believe that a nonlinear model is more appropriate. Here we see nicely scattered residuals, and this is always very tricky because you are looking for the lack of a pattern. Those classic patterns are the up, down, up, or the down, up, down pattern, which might lead us to believe that the data would be better explained with some sort of a curve. Okay, great job, everybody. Do you need to put context in this part? I would say your goal should be context for every part. However, technically, I believe if we look back at the rubric, and those will be posted this afternoon, this particular part was not looking, did not require context. The reason for that is that basically the other 4 parts of this question did. Now, let's be very, very, very clear. I don't believe for 1 second that you're going to have a 5-part regression question in 2020. There's no way, okay? But any 1 or 2 of these 5 questions would be a really tasty little piece. And to have students interpret a residual plot, I believe could be a very attractive question. That was a really nice question that popped up in the chat. Do you need context? Context is always good. Context is always encouraged. So I don't want to lie. I'm pretty sure in grading this question, context wasn't, in the grading part A, context wasn't required, because as you're going to see, it comes up in the other parts. My advice is context everywhere. You can't give too much communication. Also, sometimes context in part B can cover you in part D. Okay, so remember that interpreting output from technology is still a part of the course, even though we're not requiring students this year to have a graphing calculator. So one of the ways that we do that is to look at regression output. It's one thing that keeps everybody consistent. So looking at that regression output, we have a model. Y hat equals 2939.93 plus 233.517x. And then we always want to define our variables. If you're writing a model, you are defining your variables whether or not it asks you to, where X is the number of years since 1990 and Y hat is the predicted number of commercial aircraft flying in the US. You can make all kinds of mistakes, but if you leave off the word predicted, average, estimated, some wiggle word, and this is a line of prediction, so I always use predicted. If you leave that word out and you say Y or Y hat is the number of commercial aircraft, your grade just dropped the level. That's the most important word in that sentence, okay? Obviously, we would like students to be able to distinguish a slope and intercept, but the truth is almost all students can. That's not that hard. It's the fact that this is not a geometry exam. This is a statistics exam, and this line is a line of prediction. It's not the same line that we interpreted in geometry class a number of years ago. Part B asks us to interpret the slope. So for every year that passes, we predict an additional 233.517 commercial aircraft flying in the US. You noticed here we have context, and we have that word prediction, okay? We interpret the intercept. In year 0, which is to say 1990, we would predict 2,339.93 commercial aircraft. That was part C of the question. Part D, I'm going quickly because I would like to hopefully get through 4 of them, and we've got some Zoom polls coming up. So there's places I'm planning to stop, but these I'm going to kind of go through. What would we predict in 1992? So now we're actually being asked to do some math, but all that we're really asking you to do is to show your work and to plug the number 2, representing 1992, into this model. And to get a result, we would predict 3,406.964 commercial aircraft. And then question E, which is quite challenging, is what is the actual in 1992? So the formula for residual, every student needs to walk into this exam knowing the formula for residual. And where do we learn residual? AP statistics. And what's the formula for residual? AP, actual minus predicted. So we look at the graph. The residual for the graph is 40 for 1992. So therefore, the actual would be 3446.964. Actual 3446, predicted 3406, residual 40. Residual AP. It's vital that you don't do it in the reverse order. Residuals take a sign. So here we have this sort of nice question about interpreting 2 variable data. Starts out a little bit challenging, looking at a residual plot. It then gets sort of easier, slope, intercept, and then it ends by asking you actually to make sure the student knows what a residual is. Okay, great. So now let's jump on to our next unit. please feel free to throw up questions. Do want to get through 4 units, and I think we can do that in half an hour, get through the next 3. We're going to talk about experimental design and sampling. So how are we going to approach free response questions in the experimental design world? Okay, then it's all about vocabulary, 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 vocabulary. There's a number of different sampling methods that students are expected to understand, be able to simulate, and be able to discuss. Simple random sampling, stratified random sampling, systematic sampling, cluster sampling, convenient sampling, was taking a census, which is technically not a sampling method. Systematic sampling is technically new for the 2020 exam, but teachers have been teaching it for years, and it is absolutely fair game. It's supposed to have been taught this year. We want to talk about mitigating bias, and bias we know is systematic error. The important thing, if we have a question about bias, and if we really want to get to the heart of experimental design, then we really want to get to the heart of lessening or mitigating bias. And the big thing with bias is, if you're asked about bias, you need to give direction. So if I ask you, how would it be biased to survey students in the boys' locker room at 5 o'clock at night at your high school to find out their height? And you wrote it might be biased because you might be interviewing students on the boys' basketball team. That's not a complete answer. You're correct. If you're interviewing basketball players, that's going to give you a biased result. But why? So if you said something like, it would be biased because I'm interviewing basketball players and they tend to be taller than the average student, now you've explained the systematic error. You're going to get students that are uniformly taller than the average kid. So how do we take an answer that's a good answer and make it a perfect answer? If the question is about bias, we absolutely need direction associated with it. Okay, we want to make sure that we can do a random number table or random number generator simulation, which is to say how you would pick names out of a hat. Random number table, which is very antiquated, but a nice, easy way to do it is using the acronym STARS: start, assign, ignore, repeat, stop. Where would you start on the table? What numbers would you assign? What numbers would you ignore? What would you do about repeats? And when would you stop? The reason that's such a powerful acronym is because students tend to forget to write what they're going to do about repeats and what they're going to do if a number comes up and they want to ignore that number. So if you address those 5 things, you will always write the perfect random number table or random number generator simulation. I missed Laura Shoup just posted something about saying random, but I couldn't read that. Dr. McGuffin or Aaron, could you read that comment to me? Is that possible?
Yeah, it says, my students are in love with saying random assignment eliminates or reduces bias.
Okay, well, it does, but the question that might come up, because they're not wrong, right? It reduces bias. Random assignment reduces bias. That's going to come up in the AP question in 2 seconds. The question is, if they ask something specific in context, like, how is this method biased? And you need to not only say, basketball player, you might interview the basketball team, but then you might need to say basketball players are generally taller. We need that direction. So they're right. We want random assignment. We want random selection. We want to be able to talk about observational studies versus experiments. We want to be able to talk about experimental units. If they are humans, they are subjects, as well as experiments that are blind and double blind. This is all vocabulary that students should just come in armed, ready to use and ready to talk about. Placebo, the placebo effect. We'll talk about confounding variables in about 5 minutes. And finally, I don't know, could we do a question this year about blocking or about match pairs? The AP writers tend to love this topic because it's a really unique AP statistics topic. You don't find blocking in other subjects. It's really an AP stat topic. That's where it's introduced. In my years of teaching AP, I'm on year 16. I've mentored a lot of new teachers, and probably the number one question, sort of sheepishly from new teachers, although I wish they weren't shy about it, is, hey, what's the distinction between stratified random sampling and blocking? Because they really seem to be the same, right? And the answer is they start off the same. In stratified random sampling, we are stratifying the population. And in blocking, we are blocking or breaking up the population into similars. That first step is the same. The difference is blocking is an experimental technique. So what are we doing? Once we have those blocks, we are assigning treatment and control randomly within each block, versus stratified sampling, where we are taking each and we are taking a sample, usually RS, from each strata. But the reason it's so easy to confuse them, one's a sampling method and one's an experimental technique, is that they start off really with the same first step. Okay, so let's now jump to back to our question packet, and I will take a second and look at this question with you. And we have a slightly harder Zoom poll coming up, so get ready. Dentist in a dental clinic would like to determine if there is a difference between the number of new cavities in people who eat an apple a day and in people who eat less than one apple a week. By the way, this one is also from the 1999 exam, so quite old. They're going to conduct a study with 50 people in each group, 50 clinic patients who report that they routinely eat an apple a day, and 50 clinic patients who report they eat less than one apple a week will be identified. The dentist will determine the patients and their records to determine the number of new cavities patients have had over the past 2 years. So the patients are going to report that they eat an apple a day, and some patients will report they eat less than one apple a week. And then the dentist will examine those patients and we'll see how many new cavities they've had over the past 2 years, and they will then compare the number of new cavities in the two groups. And part A said, why is this an observational study and not an experiment? Now, my guess is what has popped into your heads, and I hope, is that there is no treatment imposed. We are looking at the cavities in the mouths of students that eat an apple a day and patients that eat fewer than one apple a week. Here's a question. When the AP readers were reading this question in 1999, it was a little before my time, what is another valid reason that they would have accepted why this was not? So we're going to do a Zoom poll. Let me read off the answers to you first, okay? A, the results only apply to these clinic patients, so it's not an experiment. B, the patients are self-reporting their apple consumption and they may lie, therefore it's not an experiment. C, there was no random assignment of patients to treatments, therefore it's not an experiment. Or D, the patients know whether or not they have eaten apples and whether or not they have cavities, so do the dentists, therefore it is not a valid experiment. Mr. Timmons, if you could throw up a Zoom poll, please. And what I would like to know, and like I need to do on my laptop here, I need to kind of scooch the poll over to the right, which you can do. So what I would like to know is, give me another reason why this is not a valid experiment. What we're doing is we have patients. Hopefully you have the question in front of you. Getting a lot of different answers here. Patients report how many apples they eat, at least one a day or fewer than one a week. And then we look at them to see if they have cavities. We're at about 16. No, we're doing great here. We're at about, looks good. I think we're back up. We're over 20. So great, Mr. Timmons, if you'd shut that down. The correct answer is in fact C. Great job, everybody. Okay. There is no random assignment of patients to treatment. Let's be clear. The other elements here, the results apply only to these clinic patients, so that does limit the scope of the study. Patients are self-reporting their apple consumption, they may lie. Okay, so that might make it a bad study, but it's still a study. And the patients know whether or not they have eaten apples, whether or not they have cavities, so do the dentist. So this sort of gets into, if it were an experiment, it wouldn't be blind, right? But A, B, and D isn't the reason why it's not an experiment. However, experiments must have, let's make sure, there we go. If we have an experiment, we must have three things. There must be randomization, there must be replication, which is to say multiple subjects or multiple experimental units, and there must be a control or a comparison group. We don't have time right now to sort of go through all those things, but if you're given an experiment, you need to check off all three of those elements. Those are the required elements of the thing. Is C not the statement in the original question? No, it doesn't say there's no random assignment. So it's not, no. But that was one of the two answers, one of the valid reasons why the readers accepted why this was an observational study and not an experiment. Okay, great. Let's look very quickly at the rest of the questions. Now, part B asks about confounding. Okay, what is an element of confounding? This is, again, a way a really bright student can lose a point if they write about confounding, they know what confounding is, but they fail to connect confounding. They fail to connect the apples to the variable, which in this case is dental health. Confounding would occur if patients who eat an apple a day differ from those who eat less than an apple a day. So there might be something very different in the behaviors of those patients that eat an apple a day versus those patients that eat fewer than one apple a week, period. That would not get you full credit. It wouldn't get you zero credit either. That's probably what we call a P in AP statistics, half credit, okay? What you then needed to do, and this is the hard part to bring it home, is connect it to dental health. Students who eat at least an apple a day might be spending so much time eating apples that they forget to brush their teeth. Okay, I'm being somewhat ridiculous, but clearly I've now connected eating a lot of apples with something about dental health. The more obvious answer is students that eat many, many apples probably are not eating candy and therefore are getting fewer cavities. So maybe it's not about the apples, it's about the failure to eat sugary candy. Either way, it doesn't really matter what direction you go as long as you connect the apples to the dental health. And then finally, part C was about cause and effect. In classical statistics, which is what we're learning in AP Stats, we cannot conclude a cause and effect relationship if we don't have an experiment. The readers also accepted that you can't conclude cause and effect because we might have confounding. So this is another classic AP setup where you can use the answer from part A or part B to correctly get part C. Okay, great. Now we're going to talk about probability. So we're now on to the third unit. We're doing great, right on time. The most important thing for probability is to show work. So for those people that are thinking you might want to handwrite your exam, this would be the one section where you got to pick one. It's either going to be computer screen or handwriting. And I would be concerned if the probability got really hairy. That's why I don't think it's going to be, because in terms of equity, we know that this exam is going to have to be constructed in such a way that students can type their answers. So this is my conjecture in red. I think the probability problem is going to involve writing. I think it might involve describing independence versus a mutually exclusive, disjoint probabilities. I think if there's a question with binomial, it won't be a calculation. Remember, you have to behave as if you don't even have binom CDF in front of you. But we might talk about why something is binomial. And remember the conditions for binomial. Binomial, independent, a fixed n, and a fixed probability of success. We call that BINS. Most teachers use that acronym. Why a variable is geometric. I doubt this will be on the exam. We have, there's only 2 questions. I doubt they will spend a part of one of them on geometric probability, but it is technically fair game. If it's conditional probability, I cannot imagine they would ask you to do Bayes' rule, because that really involves having a piece of paper. But I could certainly imagine, and this was first conjectured by Tabor and Starnes in a presentation they did a couple of weeks ago. I found an AP problem, which is very similar to that they created, but it has a really nice part. So let's look at a question 5 from 2010. Again, this is a question that you maybe are a little less likely to be familiar with. Not only is it 10 years old, but it comes from the B form. Now, you notice I have crossed out Part D here because Part D involves chi-square. So that's not relevant for this year. But let's look at this two-way table. An advertising agency in a large city is conducting a survey of adults to investigate whether there is an association between the highest level of educational achievement and primary source for news. The company takes a random sample of 2,500 adults in the city, and the results are shown in the table below. So now we have this two-way table, and the two-way table shows you the highest level of educational achievement and the primary source for news for a series of people who were not high school graduates, who are high school graduates, but not college graduates, and will have college graduates. So we have this classic two-way table. And if we think about it, there's so much they can ask from this two-way table. They could go all the way back and ask about observational studies and experiments from a two-way table. But now let's take a look at the questions. So the first question is, if an adult is to be selected at random from the sample, what is the probability that the selected adult is a college graduate or obtains news primarily from the internet? So the question is, are they a college graduate or do they obtain news from the internet? My question to you, Aaron, Zoom poll number 3, is what rule is being tested here? So the question is, what is the probability that we select somebody who is either a college graduate or obtains news from the internet? And the possible answers are addition rule, multiplication rule, Bayes rule, or the rule of threes. So Mr. Timmons has put up your Zoom poll. And again, since this is going to be a very different kind of exam, while you're thinking about this, one of the things that we have to think about is how they're going to ask a probability problem, which is over 30% of the course in an exam that may be typed in Google Docs. So we have some answers coming in. We have a couple of people that are looking at conditional probability and Bayes rule, and the majority have fewer people answering this one. So this is the third question in the packet, question from 2010, question number 5. And we'll give you a couple more seconds. I promise the next 2 Zoom polls are more fun. Okay, I think we're back up to roughly 20 people there. 19, there we go, we just hit 20. So that's good, let's shut that down, Mr. Timmons. And sure enough, this is the addition rule for non-mutually exclusive probabilities. We usually just call that the addition rule. So great job, those of you that picked it. Let's take a look at all the different probability concepts that came up in this AP problem. Part A was the addition rule. The probability of college graduate or internet would be the probability of A plus probability of B minus the probability of both. And I've done that math here. You can see it's 4-function calculator math. A probability of A plus probability of B minus probability of both, all over the total number of people. Part B was conditional probability. It asked for the probability that someone likes the internet for their news, given they're a college graduate. And if you were typing this, you could certainly type out the word given. You don't need that vertical line, which is sometimes a little tricky to find. I found it under symbols in Microsoft Word. So that's 245 over 693. And this final part, part C, this is my big gamble. What is going to be the challenging probability problem in 2020? Now, I don't know the answer. I don't have any insight into what's going to be on the exam. If I did, I wouldn't be allowed to run the session. But my guess is, since we know that you're not going to need a graphing calculator, how can they ask a challenging probability problem? And the one that usually gives students fits, and we know the AP is this question of independence and drawing these numbers from a two-way table. So the question here is, are they independent? There's a couple ways to solve it. The way that I solved it using the previous answers is we know that if events are independent, the probability of A should be equal to the probability of A given B, which is to say the probability that a student, that a person likes to get their news from the internet should be equal to the probability that a person gets their news from the internet given they're a college graduate. Well, in fact, those two fractions are not equal to each other. And that's for a function calculator, very easy to type, and therefore we have evidence these variables are not independent using the two-way table. I'm a big fan of this question. I torture my students with it regularly, and my guess, this is purely conjecture. Thank you, Monique. That's very helpful. She just put in the chat there where to find that vertical line. Again, you can write the word given. That's fine as well. This is one of the trickiest probability problems that would really lend itself very well to the format of this year's exam. So that is purely Mr. Shrager's conjecture. Okay. Okay. So finally, let's talk about inference. So we know in a traditional year, inference is 40% of the exam. We don't know how that's going to play out this year since we've lost chi-square and inference for slope, but we do know it's going to play a big role. So what do we need to be able to do? Well, there's a really strong likelihood that we'll be asked to, given a scenario, what test would you run? So the last 3 advanced Kentucky sessions really focused on what test would you run. One trick that students seem to really like is, even though you don't need a graphing calculator this year, most students have one at home. And if you have that, so you just type stack tests, and now you basically have a list of nearly every test and interval that we use in the class. One exception, of course, is the max pairs t-test. That's the only one that's not on the list. First thing I have my students do is tell me, is this a question about means or is it a question about proportions? And then we think about, is it 1 sample? Is it 2 samples? Are the samples independent? So that's a thought process, and it's something that's really worth practicing over the course of the next 3 weeks. Okay, it is vital to define your parameters. I like to use the word true or actual or population. True is a really nice word. The true, mean, or proportion. This is what readers are looking for. The worst thing you can do, the biggest mistake you can make, is to say that the parameter is the sample of students that were tested. We never want to perform inference on samples. That is a gigantic error. Okay, that can take a great answer all the way down. Okay, we may need to interpret a confidence interval. We may need to look at whether a certain value is in an interval. Our guess this year is that that interval will be given to us. Probably unreasonable to ask students to calculate that interval and show that interval calculation without a graphing calculator would really lead to a disconnect in the equity of people taking this exam. Interpreting a p-value is a less than alpha, and of course, we never ever accept a null hypothesis. We don't write the words accept the null, and we don't accept it in words. And finally, define confidence level. This is one of the trickiest questions of all, and it's usually what is meant by 95% confidence. It's a classic AP question. It's one that just involves words. In repeated sampling of this size, 95% of such samples will generate intervals that contain the true parameter. Okay, so we got a couple questions last week, and we got a couple questions the week before, and there seems to be a lot of questions about type 1 and type 2 errors, and that lends itself very well to this year's exam. So let's have a Zoom poll about type 1 and type 2 errors. Okay, ready? So let me read this to you. This is a question that I wrote. After running my appropriate statistical test, I make the conclusion that I cannot reject the null hypothesis that Tammy really likes me. I do not reject the null that Tammy likes me. Unfortunately, I am wrong, and Tammy finds me repulsive. What type of error have I made, and what is a potential consequence of this error? So I failed to reject the null that Tammy likes me, but I am wrong because she finds me repulsive. So what kind of error is this? Type 1, consequence. Tammy and I get married and we live a long and happy life together. Or is it a type 1 error in that I don't ask Tammy out? I should have asked her out. We could have had a wonderful life together, but instead I live the rest of my life alone and sad. Perhaps this is a type 2 error. I don't ask Tammy out. She didn't want me to, so I marry her best friend and everybody lives happily ever after. Or is this a type 2 error? I ask Tammy out. She rejects me. I'm humiliated and I simply stop dating. Okay, so Mr. Timmons, if you could put up the Zoom poll. I know you may need to move it over because there's a lot of words on this page. And the question is, what kind of error have we made? And what is a consequence of this? I failed to reject the null that Tammy likes me. I am wrong and Tammy finds me repulsive. What error have I made? And what is a consequence of this error? It's a tricky question. Gets at the heart of a very big topic in AP statistics. The AP writers and the stat teachers, we love talk about type 1, type 2 errors because this is a topic we say often that statistics is a science that is in service to other sciences, and nearly every science, social science and hard science, has vocabulary for type 1 and type 2 errors. Good. Okay, we can close this poll, Mr. Timmons. Everybody nailed this. It is 17 people said that, in fact, this is a type 2 error, and the consequence of this error is that I'm humiliated after asking Tammy out, and the consequence is that I am sad and lonely. This, by the way, I know hopefully you got a little chuckle, but identifying an error, writing a consequence is a very popular AP problem. And again, I know I'm a broken record here. It lends itself very, very well to the format of this year's exam. Okay, so let me scroll forward here. And now let's pull up the final question in our packet. And the final question in the packet says, when a law firm represents a group of people in a class action lawsuit and wins that lawsuit, I'm sorry if that was a hard question. It was hard for me too when Tammy rejected me. So whoever wrote that in the chat, okay, that was a joke. I don't know it, Tammy. I ask that question to my students every year, but I have to make absolutely certain that the name that I use in the question is not a name of one of my students, because that would be creepy and weird. Okay, so back to this. Here's the actual question from 2003. Law firm represents a group of people in a class action lawsuit and wins that lawsuit. The firm receives a percentage of the group's monetary settlement. The settlement amount is based on the total number of people in the group. The larger the group and the larger the settlement, the more money the firm will receive. A law firm is trying to decide whether to represent car owners in a class action lawsuit against a manufacturer of a certain make and model for a particular defect. If 5% or less of the cars of this make and model have the defect, the firm will not recover its expenses. Therefore, the firm will handle a lawsuit only if it is convinced that more than 5% of the cars of this make and model have the defect. The firm plans to take a random sample of 1,000 people who bought this car and ask them if they experienced this defect in their cars. Define the parameter of interest, state the null and the alternate, and describe a type 1, type 2 error, and let's describe the consequence. Okay, so I want to make sure that we get to wrap this up because I do have some closing strategies for you. So let me run through this sort of quickly. This has been the focus, really, the last 3 Advanced Kentucky sessions. So I'll go through this a little faster. The parameter of interest is the portion of all cars that have this defect, or the true portion of cars that have this defect. You notice that I highlighted the words all and true. This is what the readers are going to look like if you're asked for a parameter. I force my students every time they see the word parameter to write the word all. I don't give them a choice. I want to see all. Okay. Null hypothesis, something like P equals 0.05. Alternate hypothesis, P is greater than 5%, where P is the true proportion of cars that have this defect. The question didn't ask to define it because you defined it up here. Then part B, type 1 error. The law firm believes the portion of cars that have the defect is greater than 5%, but it isn't. consequence, take on the case, but they shouldn't have, and they don't recover expenses. And the question that just came up from Kemp is, will they be expected to use subscripts? I would say absolutely not. And I actually intentionally, thank you for catching that, I typed this ho and this ha, this null and the alternate, without hitting the subscript key, so we could see how it looked. So I think if you are typing a null and an alternate, you are not going to have to use a subscript key. Hey, you could even write the words null and alternate if this were a question this year. And then it also asks you for type 2 error. This is an awful lot of writing for a question, but I could certainly imagine the exam asking you to identify the error and give a consequence. This particular question, in the traditional hour-and-a-half free response format, asked you for both types of errors and for 2 consequences. Here, a type 2 error would be that the law firm is not convinced the portion of cards that have defect is greater than 0.05, but it is. The consequence is they lose an opportunity to make money. Okay, great. So let's talk very quickly about defining this. And then I have one more Zoom question for you that I think is a fun one and hopefully a little bit challenging. Type 1 error, rejecting a true null. It's locking up an innocent person, okay? Sometimes we call this the Shawshank error if you've seen the movie Shawshank Redemption, okay? Probability of a type 1 error is defined as your alpha value, vital fact for the AP student to know. Probability of a type 2 error, failing to reject a false null. So finding a guilty person innocent. I'll fix that spelling error, I apologize. And probability of a type 2 error is not an AP stats concept. So we're not going to worry about that probability, except it is 1 minus power. Is an AP stats concept that is vitally important to be able to discuss and to be able to communicate. It is the probability of correctly rejecting the null. It is the reason people go to medical school, because they want to identify when someone is actually sick and make them better. They don't want people to be sick, but if someone is sick, they want to reject the null that they're well, they want to get them better. So I like to say medicine has gotten more powerful over the last 100 years. We have an MRI machine that can correctly diagnose a torn ligament and a damaged ligament much more effectively than before this device was invented. So the MRI has made medical science more powerful, okay? So here we go. We have one more Zoom poll, Mr. Timmons. Which of the following scenarios would have 100% power, okay? A home pregnancy test that always gives the right answer. A home pregnancy test that always tells everybody they are pregnant, including men. A home pregnancy test that always tells pregnant women that they are pregnant, but is extremely unreliable for those that are not pregnant, or all of the above. So which of these, power is big idea, P stats, and I want to know which of these would give us 100% power. A home pregnancy test that is always right, a home pregnancy test that tells everybody they're pregnant, a home pregnancy test that tells pregnant women that they are pregnant, but is extremely unreliable for everybody else, or all of the above. Okay, we have some nice distribution of answers here. Take a second and read this. This is really worth your time. This is a high-level AP concept. If we think about 100% power, and we see the answers coming in. I have 16 answers, and we've been gunning for at least 20 every time. So the answer is still coming in. We are now at, let's see, I'm seeing 18, I'm seeing 19 answers. Give me one more answer. Okay, 19, 20 people have now answered the question. All right, so we've broken our streak. The answer is not A. 100% power implies that we always reject a false null. So let's think this through. This is a very big idea. The null hypothesis needs to be that we are not pregnant. I think we can all agree that the status quo for people walking the earth the huge majority of us is that we are not pregnant. So why does one take a home pregnancy test? In order to identify whether or not they are pregnant. So that would be the alternative hypothesis. Power is the probability of rejecting the null when the null is false. So if we were to reject 100% of false nulls, always telling pregnant people that they are pregnant, all three, A, B, and C, all do that. Now, they have a tremendously high number of type 1 errors, but that's not what the question says, okay? So we want to tell a pregnant woman that she is pregnant, and A, B, and C all do that. So everybody, thank you very much, Aaron, for putting that back up. So for the three of you that picked D, great job. Really impressive. This was not an easy question at all. You need before exam day to really review type 1, type 2, and what the heck is power? Power is a probability calculation. It is the probability of correctly rejecting a false null. It is the likelihood that I tell a pregnant person that she is pregnant. And if I simply marketed a test that told every single person on the planet that they are pregnant, it would be a completely useless test, but it would have 100% power. Okay, great. Sorry to deflate the room a little bit, but I wanted one challenging question, and I know how important this topic is. Now, we've looked at 4 AP problems over the course of an hour and minutes. What did these 4 problems have in common? I picked them because they were a little bit old and maybe a little bit less known, but I believe these 4 questions have one important thing in common, and that thing is there was no graphing calculator functions at all. You did a little bit of fractions on the two-way table, so it felt like there was a little bit math, but it was all conceptual. And there was no normal CDF, there was no binom CDF, you didn't need Bayes rule, there was no test functions, you didn't have to calculate an interval. We have 4 questions with no graphing calculator, and that's the 2020 AP exam. Okay, so we know we're going to have 2 questions, and we know they're going to cover multiple units, and we know you're not going to need the calculator. This year, more than any other year, it's going to be about writing, it's going to be about communication, and it's not going to be about calculation. We're going to ask students to demonstrate their knowledge in a series of easy, moderate, and challenging problems. So this is my very final slide. So thank you so much for staying with me 5 minutes late. I sincerely appreciate it. And I will stay, as will Mr. Timmons and Dr. McGuffin. If you want to throw questions in the chat, I'll stay as long as you'd like. This year, how is this year different from all other years? Because it is different, and we know that. I'm speaking to you from my office, and I have a cat asleep on the couch behind me. I'm surprised you haven't met him. Don't focus on calculator commands or methods. Calculations are minimal. It's all about interpreting intervals, interpreting hypothesis tests, and justifying claims we can make. When there's a probability problem, we still need to show work. The readers are still going to look for work. No naked answers. No bald answers. There's a lot of terms that we use at the AP reading, but we can't just have a number. You're going to have to show work. There's going to be probability problems. So I'm going to go out on a limb here, and I'm going to tell you I think you're going to write fractions. That's my guess. That's considered showing work, okay? Be prepared to give example of sampling methods or to write how you might run an experiment, but use vocabulary carefully. Don't throw in fancy stat words because you think they sound good. If you don't know how to use a word, use a simpler word, please. This is my final tip. When the AP readers read your responses, partially wrong is wrong. We can't give you credit for what you wrote that's right if it includes something that's wrong. So if a student writes, this is an observational study because no treatment was imposed, extrapolating in this bad statistical practice. Well, extrapolating is a bad statistical practice. It is. But the question about observational studies and treatments was about apples and dentist cavities, and there was no regression. And extrapolation is a term in AP statistics for predicting outside the range of our independent variables. Dr. McGuffin just wrote the most important comment of the day. She wrote less is more. Okay? We are looking for complete answers. We are looking for good statistical communication, but be super careful, because if you misuse a word, especially on a shorter exam, and in that last sentence, this is an optional study because no treatment was imposed, period. If that's all the student wrote, they would have gotten the perfect answer. And then extrapolating in this manner is bad statistical practice. And every reader that's on this call, Mrs. Rice, Dr. McGuffin, Mr. Lachelle, and any of the other readers that are on the Zoom call, they're all saying the same thing in their heads right now. They're saying the student just shot themselves in the foot, because they started out by writing exactly the right answer, and then they proceeded to write something which sounds kind of, I made it up, but it's incorrect. It's an incorrect use of a statistical term, and it will result in losing points. And that is the end of the presentation, and we are an hour and 9 minutes. I apologize for going over. And Mr. Lachelle just wrote, we hold our noses often as well. Sometimes we do make the judgment to overlook a wrong word, but let's not gamble like that, Mr. Lachelle. Let's instead try to use the correct terminology as often as possible. And if you're not exactly sure how to use a word, use a different word, or just explain it in simple English, because using a word incorrectly can really hurt your score, especially on a short exam. Mr. Timmons, let me turn it over to you.
All right, thanks, Adam. Really good job. I think everyone appreciated the extra time you went over, so no concern here. All right, let me share a little bit of wrap up here. So contact information for Advanced Kentucky, myself, Dr. McGuffin, and Adam Shrager are all on this page here. Feel free to reach out to us with any questions. Adam will post updated materials to the Google Drive here this afternoon, so please make sure you go there, as well as kyap2020.com for a recording of today's session. May 21st, the day before the AP Statistics exam, we are going to be back with one final review session with Mr. Bob Lachelle, 2 p.m. Eastern Time. You do need to register for that, but that link can be found at kyap2020.com. So all of you out there that have last-minute questions the day before the exam, this will be your opportunity to jump in and ask some pressing questions that you have, get your minds put to ease before the exam the next day. So we encourage all of you to join. Please spread the word. We welcome everybody to participate. So I don't see any other questions. Sherry, Adam, do you? If not, we will go ahead and sign off here.
For all of the Hapra Horsham students, they need to know that Mr. Lachelle absolutely loves Smarties. They are his favorite candy. Under no circumstances should anyone buy him Dove chocolate. But if you're looking for a nice end-of-year treat for Mr. Lachelle, those Smarties candies, that's his favorite. Everybody needs to know.
I think that's parting words there. So
yes, it is. And any other serious questions or thoughts? Be happy to stay on if anyone has questions from the perspective of a guy who's going to be reading these exams. That's, you know.
All right, I'm going to go ahead and stop the recording. If you have chat questions, though, you can continue to post those here for the next couple minutes. But we thank you all for joining, and we hope to see you on the 21st. Until then, take care.